So in this question we have jerry cans and all of them are mathematically similar. So a jerry can that you put fuel into, and the UK regulations have a maximum limit of 20 litres on one can. But this company makes multiple jerry cans that are mathematically similar, and the smaller one has a height of 34 centimetres and it can fill 12 litres at most. So we have to find the maximum possible height of a jerry can. Now the maximum capacity is 20 litres, so we have to use similarity to find the maximum possible height. So what you should know is we will have two jerry cans. In fact, we'll have the small one. The diagram is rubbish. Right. I know it's bad, but so the small one, and it's got a height of 34 centimeters and a capacity, we'll call that V, is 12 litres. And we then have the large one, and the large one is the maximum capacity of 20 litres. But we don't know the height, and that's what we want to find out. Let's call it X. Now, what you should know here is that the large volume is equal to the large height divided by the small height. Cubed multiplied by the small volume. So this here is the linear scale factor. But we have to cube this because we're dealing with mathematical similarity in 3 dimensions. We're dealing with volume, so we have to cube it, then we get the volume scale factor. So this is the linear scale factor in circled in red, and this in green is known as the volume scale factor. So the large volume is 20. We don't have to write it in centimetres cubed. We can keep the units of litres. The large height is X. The small height is 34 centimetres. And this is cubed to get the volume scale factor. And we multiply by the small volume of 12 given in the question. So we need to do some rearranging to then get X on its own. The 12 is being multiplied, so we divide both sides by 12. And we get X over 34 all cubed. Now, the inverse of the cube is the cube root. So if we take the cube root of both sides, we get x over 34 on the right hand side. And we take the cube root of 20 over 12. And x divided by 34. But if we then multiply that by 34, we get rid of the 34 on the denominator on the right hand side. So x will be given by 20 over 12 to the power of 1/3, which is the cube root, all multiplied by 34. And we're not told the rules about rounding, so I'm just going to put this into the calculator, and 20 divided by 12, then cube root it and multiply by 34, and the answer I get is 40.3146 centimeters. I'm going to give this to 3 significant figures. The maximum height will be 40.3 centimeters. And we've now finished. So I hope you found this video useful, and once again, best of luck with the studying.